Welcome to Day 6, Formal Languages and Automata Theory. In this session, we will explore formal languages, finite automata, context-free grammars, and push-down automata, which are foundational to computer science, especially in areas like compiler design, programming languages, and syntax analysis. Let's begin by understanding what formal languages are. A formal language is a set of strings formed from an alphabet and governed by specific rules or grammar. These languages are crucial because they provide the basis for designing programming languages, compilers, and interpreters. Formal languages are widely used in fields such as syntax analysis, pattern matching, and natural language processing, enabling computers to interpret and process structured data. Now let's dive into finite automata. Finite automata are computational models used to recognize regular languages. They are simple machines with a finite number of states that can process input symbols one by one to determine if the string belongs to a given language. There are two types of finite automata, deterministic and non-deterministic. A DFA has exactly one state transition for each input symbol, whereas an NFA can have multiple state transitions for the same input symbol. Let's consider an example of a DFA and NFA recognizing the string that end in 101. Next, we will discuss regular languages. These are languages recognized by finite automata. Regular languages have some important properties such as closure under operations like union, concatenation, and clean start, making them quite versatile. Regular expressions are a key tool for describing regular languages. They provide a convenient way to define patterns in text, and they are equivalent to finite automata in power. Moving to context-free grammars. A context-free grammar is a formal grammar used to describe the syntax of programming languages. It consists of non-terminals, terminals, a start symbol, and production rules that define how strings are generated. An example of a context-free grammar is one that defines simple arithmetic expressions such as expression assigned, expression plus term. These grammars are essential for the syntax analysis phase in compilers. Now let's explore pushdown automata. A pushdown automaton is an extension of finite automata that includes a stack. This allows it to recognize context-free languages, making it more powerful than finite automata. Pushdown automata are particularly useful for recognizing nested structures such as balanced parentheses in programming languages. This makes them ideal for parsing nested expressions. Formal languages have various practical applications. Finite automata are used in lexical analysis for tasks such as tokenization. For example, regular expressions can be used to validate email addresses or match URL patterns. Context-free grammars are commonly used in compilers to analyze the syntax of programming languages. Pushdown automata are particularly useful in parsing structures like nested parentheses in expressions. Let's look at some practical examples. A DFA can be used to recognize binary strings that end in 101. Similarly, a context-free grammar can be used to define arithmetic expressions like x plus y times z. Pushdown automata are well suited for recognizing balanced parentheses in strings like this. These practical examples illustrate the relevance of formal languages and automata theory in real-world computing. As we move to advanced topics, let's discuss the limitations of finite automata and pushdown automata. Finite automata cannot handle nested structures such as palindromes, and pushdown automata are limited to context-free languages which exclude certain complex structures. Turing machines extend beyond finite automata and pushdown automata. They are a theoretical model of computation that can simulate any algorithmic process, making them fundamental to the theory of computation. In this section, we will work on some hands-on activities. First, you can try writing regular expressions to validate email addresses. This will give you practical experience with pattern matching. Next, you can design a finite automata or NFA to recognize a specific string pattern or implement a context-free grammar to parse simple expressions. Lastly, simulate a pushdown automata to match balanced parentheses. To summarize, formal languages and automata theory are essential for understanding the fundamentals of programming languages and compilers. Finite automata, context-free grammars, and pushdown automata are tools that help us recognize and parse languages, which are crucial in computer science and software development. Thank you for joining today's session on formal languages and automata theory. I hope you now have a deeper understanding of these important concepts and their applications. Don't forget to explore the hands-on activities to strengthen your knowledge.